Let's state the number of possible triangles that can be formed, and we have no diagram. Now we know that a triangle has angles A, B, C. Capitals mean the angle, and lowercase refers to the side length. Now we know that we have capital B and lowercase b. So let's play the sine law game. Sine B, which is 32 degrees, over B, which is 22, equals, playing catch with A, we have sine capital A, which is the angle, over the side length A. And the A happens to be 27. Let's multiply both sides by 27. We have sine A equals 27 times sine 32 over 22, which is approximately 0.6503, etc. Hitting sine inverse, we have a possible angle A as 40.6 degrees. So when the angle A is around 40 degrees and angle B is 32, you can imagine that we can find angle C because three angles add up to 180. Now be careful. Sometimes we may be having the sine law ambiguous case where we consider the possibility that A2 is going to be 180 minus 40.6, which is approximately 139.4 degrees. Again, this angle is good because around 140 degrees plus 32, we still don't exceed 180 degrees. So these two possibilities are fine. So we'll say there's two possible triangles. Let's try this second part here. We'll work with the B's first. Sine B over B equals sine A over A. Multiplying both sides, we have sine A equals 6 times sine 96 over 25, which is about 0.238, etc. Hitting sine inverse, we get A is about 13.8 degrees. So 13 degrees seems fine, 96 degrees is the other angle, and we don't exceed three angles being greater than 180. And that's our first possibility. And our A2, in case we have the sine law ambiguous case, is going to be 180 minus A1, which is about 166.2 degrees, which is quite large. Now we have a problem. When A is 166 and B is 132, when you add them together, we're past 180. So this second angle is extraneous. It's impossible. So there's only one possible triangle. Now let's try this triangle. Let's work with the B's. Sine of angle B over B equals sine of angle A over A, which is 23. Multiplying both sides by 23, we have sine A equals 23 times sine 34 degrees over 7, which is about 1.83. Now we have a problem. When we hit sine inverse to find the angle A, it gives us an error. So there's no possible solutions. There's no triangles whatsoever. In general, sine of some angle as well as cosine of some angle must be between positive 1 and negative 1. Let's try one more. Here we have angle A is 30, so let's draw this out here. Angle A is approximately 30 degrees right there. And we have AC and BC. So let's just draw some sides here, and we can see that AC is longer than BC. So let's make this shorter part, BC, is 5, whereas AC will make this 8. And let's ask ourselves how many possible triangles. So even though this triangle is not completely accurate, we can still use the sine law, playing catch. So we'll say sine B over 8 equals sine A, which is 30 degrees, over 5. Thus, sine B multiplying both sides by 8 is 8 times sine 30 over 5, which is about 0.8. Hitting sine inverse, we have our possible B value of 53.1 degrees. 53 and 30 seems small enough, so this is correct. Now let's try 180 minus B1. We have B2, which is 126.9 degrees. Although this is large, 127-ish, when we add 30 to that, we do not exceed 180 degrees. So there's two possible solutions, two triangles.